So serverless computing is a cloud computing model in which the cloud providers allocate machine resources on demand and take care of servers on behalf of the customers. So when we think about serverless, we generally think about services like Lambda if you're working in AWS, or Function App if you're working in Azure, or Cloud Functions if you're working in GCP. But that's not true. You can also include tools like SQS, SNS, if you're working in AWS, or other application integration tools if you're using the other cloud providers as well. So these gambit of services also come under serverless. And also so does the S3 bucket and all the other storage related capabilities that are provided by cloud providers. So serverless not only means compute like Lambda and functions, but it also includes integration tools and storages. So that's one thing you should keep in mind of when you're talking about serverless. So as long as the service allocates machine resources on demand and the servers are taken care of by the cloud providers themselves, then that particular service can be termed as serverless. So now let's talk about the features of serverless. The first feature of serverless that makes it very appealing is zero administration. So here, once you have your service set up, you do not have to worry about your server, whether it's working, whether it has been patched, etc., etc. All those administrative tasks are taken care of by the cloud providers themselves. So that's one very important and very key feature of serverless. So this is a very important feature of serverless. The lookup, the administration of the infrastructure is taken care of by the cloud providers themselves. The second key feature is auto scaling. So auto scaling makes it possible for you to ramp up your infrastructure as per needs. So as your application keeps growing in size, then serverless application will auto scale and it'll use extra resources or extra infrastructure to make sure that your application is running properly. The third important feature of serverless is pay as you use. So you only pay for the resources that you have used. So let's say that you have used your Lambda application for a particular period of time. So you only have to pay for that particular period of time and not more. So this makes it quite cost efficient as well. And the fourth most important feature of serverless is increased velocity. So now that because your application has zero administration and it scales seamlessly as per your needs, it's possible for you to develop an application in a shorter period of time than you would have had to if you were not using serverless. So these are some of the key features of serverless. So on this particular slide, I have pasted a link. You can go check out that link and see the need for serverless and see all the features that are available in serverless. So now that we know what serverless is, now let's look at some of the disadvantages of using serverless. Now these disadvantages are only applicable for the compute services that are currently available. So this includes services like Lambda, app functions, or the cloud functions that are available in GCP. So the most important disadvantage is performance. Then there are the resource limits, monitoring and debugging, and the vendor lock-in and security. Now I have marked them colored as red and yellow. Now the yellow ones are probably disadvantages that can probably be bettered later on. So monitoring and debugging tools currently are quite rudimentary in some of these services, but gradually they will get better. So now let's look at some of the more critical problems of using serverless. The most important problem is, again, like I said before, performance. And this is related to a concept called cold start. So now let's look at what cold start is. Now the most critical aspect of performance is a concept called cold start. So the cold start can be defined as the setup time that is required to get a serverless application up and running when it is invoked for the first time and within a definite period. Now, cold starts are something of an inherent problem that is applicable across all cloud platform providers. This includes AWS, Azure, and GCP. So now, based on a few parameters, your cold start can increase or decrease. So the increase in cold start would inherently mean an increase in latency and a decrease in performance of your application. Now, the two most important factors are the code size and the language used. So the larger the code size of your application, the greater the cold start would be, and the lesser the performance or the latency of your application will increase. Now, similarly, another important factor to consider is what kind of language you are using, whether it's a compiled language or an interpreted language. So in the next slide, we will see the difference between using a compiled or an interpreted language. Now in AWS and Azure currently, there are ways to overcome cold start. AWS has a concept called provisioned concurrency, and in Azure you can use a premium plan and above to overcome cold start. However, these are expensive ways to overcome cold start, and it would cost you more to use these services. So now let's look at what cold start is in a more diagrammatic way. So the cold start is basically the loading of your code as a zip file, then the creation of a container, and then after that loading the runtime for your particular application to run. So these two combined together form the cold start. Now, as I said before, the larger your code size, the greater the cold start would be. And also another factor is whether you're using a compiled language or an interpreted language. So the compiled language would take more time to compile that particular code. Whereas if you're using an interpreted language, there is no concept of compilation of code. So that results in a lesser cold start if you're using an interpreted language. Underneath is a diagram to show you the difference between an interpreted language and a compiled language when it comes to the cold start execution time. So if you look at a code like Java, you can see that the cold start is initially around 300 millisecond, whereas if you're using a node based application, then it's around 3.5 to 3.75. Now there is a very good blog for this particular concept of cold start that I have linked in this particular slide. I will also mark this particular URL in the resources for this particular section. So please go through this and understand what the concept of cold start is, and this is a term that will come up across all platforms, and it is something that is not going to go away anytime soon. So now the other disadvantage of using a serverless application is that you have limited time and limited memory. That is because you wouldn't want your serverless application to be running forever. You would only want to run or execute small chunks of code for a limited period of time with a limited memory. Now, even though this is not a disadvantage, but this is something that you should be aware of. For example, at this moment, if you're using an AWS Lambda, your function cannot run for more than 15 minutes. Similarly, if you're using Azure, your function cannot run for more than 10 minutes. That is if you're using the consumption plan. These are different for the other plans, however. And similarly, if you're using GCP, the maximum that your code can run for is 9 minutes. And the same is the case with the memory as well. The maximum memory that AWS allocates for a particular Lambda function is 10 GB. And for Azure, it's 1.5, and for GCP, it's 4 GB. Now, these are limits that will keep changing. And if you look at this slide and if you see that the numbers are different, that's probably because those numbers have been changed. So I would imagine that these numbers would keep increasing. That is, the time limit would keep increasing, and so would the memory. So another disadvantage of using serverless is that you will have lost control over your hardware and the runtime. And what eventually happens is that you end up using other proprietary cloud specific tools that were making it difficult for you to move out of that particular ecosystem. So let's assume that you've created a Lambda application. Now you would want a trigger like an S3 bucket or an SQS or an SNS. So you would use that. You would also use other services like EC2, Aurora database, etc., to make a complete application out of your particular Lambda. So once you have done that, you've basically created a application which uses proprietary cloud specific tools for AWS. And once you've done that, it's next to impossible for you to change from AWS to, let's say, you want to migrate to GCP or Azure. So this is something that you have to be aware of. You should be aware of the fact that once you are stuck in AWS, then you're stuck in AWS forever, because of the fact that you would be using other proprietary cloud specific tools along with your Lambda. So that's again something of a disadvantage if you're using serverless. Okay, so now let's talk about the serverless compute services that are available in Azure. Now this includes the Azure Function, the Azure App Services, and the serverless Kubernetes. Now Azure Functions are something that we will actually deal with intensively in this course. So Azure Functions are equivalent to your AWS Lambda or GCP Cloud Functions. And Azure Functions basically would execute small snippets of code. So as we go along this particular course, I will explain to you further what Azure Functions are. Now let's talk about the second service. Now the second service is the Azure App Services. Now Azure App Service is basically the platform as a service that is provided by Azure. And using Azure App Services, you could actually build a custom website or even a mobile or a API backend. Now Azure App Service is also something that I would teach you later in the course. Now, apart from the Azure function and the Azure App Service, there's also something called as serverless Kubernetes. Now, serverless Kubernetes is something that I would explain in a different course, because to understand Kubernetes would take a long time, and to explain the serverless part of it is actually quite irrelevant unless you actually understand what Kubernetes is. So in this particular course, we'll be focusing mainly on Azure function, and we'll also be doing a bit of Azure App Service. So I'll see you in the next section. So now let's talk about the serverless database and the serverless storage services that are available for use. Now, if you're using a database and if you do not want to manage the backend servers, then you have the option of choosing between the Azure SQL database serverless or the Azure Cosmos database. Now, these two are serverless databases. Now, there are other databases that are available for use in Azure as well, but those are all servers and you have to provision servers for them. However, if you do not want to provision servers, then these are the only two options that are available. Now, this list might keep growing as time goes by. So, at this moment in time, these are the only two databases that are available. Now, if you're using your storage service, then you have the option of storage account. Now, storage account includes the blob storage. So, that's the most commonly used storage service that is available. So whenever you create a serverless application, the database and the storage service will combine with the compute service that I had shown you in the previous chapter. And combining all these three, you can create a comprehensive serverless application. So in the upcoming chapters, I'll show you how these applications can be created. So I'll see you in the next chapter. So let us start this chapter by giving you a very brief and a very concise definition of Azure Function. So Azure Function runs small snippets of code without having the headache of provisioning servers. Now, some of the languages in which you can write this piece of code includes .NET, JavaScript, Java, and Python. So now let's talk about some of the use cases of Azure Functions. The most basic use case is creating serverless APIs. Now you can have your Azure function connected to an HTTP trigger, and this can form the basis of your serverless APIs. And these serverless APIs come in handy, especially if you're making web applications which consist of just static HTML pages, and then you can actually create a very comprehensive backend using just these HTTP triggered Azure functions. You can also create microservices using Azure Functions. Now there's a very common framework called as Serverless. Now that Serverless framework can be used as a basis for creating microservices in Azure Functions. I have a separate course on Serverless and I will link that in the description below. Now apart from that, you can also create machine learning workflows and cloud automation workflows using Serverless Azure Functions. So you can run your Azure Functions in three distinct plans: the consumption plan, the premium plan, and the dedicated app service plan. So now let's look at the differences between all these three plans. So the consumption plan is the default hosting plan that is available to you. And a major advantage is you pay only for the functions that are running, and it scales automatically even during periods of high load. A major disadvantage of consumption plan is that you will have to deal with cold start. And another major disadvantage is that the maximum timeout is much lower than the premium and the dedicated plan. It is currently 10 minutes. Now this 10 minutes can keep increasing. So always look out for the current value. I will give you a link of all the latest values for these plans in the link and description below. Now another major disadvantage of using the consumption plan I feel is that you cannot connect your consumption plan Azure function to your virtual network. Now that is, I feel, a very major disadvantage, because let's say you created a Azure function and you want to connect it privately to a to a virtual machine, then you cannot do that using the consumption plan. You would need to use your premium or your dedicated plan. So now let's talk about premium plan. Now you would use premium plan if you're worried about cold start, because in your premium plan your function app runs continuously or near continuously. Now that is because at the back end there is always one server running for your function. Now this makes your premium plan a little more expensive than the consumption plan. Another advantage is that you get more options on CPU and memory than in your consumption plan, and your maximum timeout in your premium plan is much higher compared to your consumption plan. Another major advantage of using premium plan is that you have the opportunity to connect your app function to your virtual network, which is not available in the consumption plan, like I had said previously. So these are the advantages of using premium plan. The disadvantage, like I previously said, is it's much more expensive than your consumption plan. And finally, let's talk about the dedicated plan. If you want to run your function within an app service, then you would want to use your dedicated plan. This is best suited for long running scenarios where durable functions cannot be used. A major reason why you would want to use your dedicated plan is if you have an underutilized CPU that is using another app service, or another major use case is if you want to run your function on a very specific custom image, then the dedicated plan is the way to go. And also dedicated plan has a predictive scaling and costs are also required. So these are the major differences between all these three plans. So I'll see you in the next chapter. So now let's talk about Azure architecture. So whenever you're talking about Azure architecture, there are three terms that I would want you to remember. That is the trigger, the input binding, and the output binding. So the trigger is a very easy concept to understand. It just triggers the Azure function to execute. Apart from that, there is an input binding. So the input binding can be used to insert input objects into that particular Azure function. And the output objects can be used to send output out of the Azure function. So now let me give you an example of input binding and output binding. So let's say I have an endpoint to trigger the Azure function, and this endpoint getID is just to retrieve information about a user. And the user information is stored in a storage bucket table. So here the input binding would be the table, and using the ID, I can just retrieve the information about that individual user in the input object. And using JSON as an output object, I can send this particular object to the HTTP response. So that is how the input binding and the output binding works. I will give you multiple examples of this in the upcoming lectures. So let us create a first function app. Now there are two ways in which you can create your function app. One is through your console and the other is through VS Code. So in this particular chapter, we'll explain how using your console, you can create a function app. So to do that, you can go to your search and just type function app. You can also find it under the hamburger menu as well. So you can click on this function app. So once you clicked on it, you can just create a function app. So let me just create one. And here you need to give in which subscription you want your function app to be. So I have just one subscription, so I'll choose that. And then you can choose a resource group in which you want to create your function app. So you can either create a new one or you can choose an existing one. But for this example, let's create a new resource group. So let me just call this my. So this is my new resource group function app. I'll click on OK. And then you need to give a name for your function app. So let me just give us. And then you need to choose between code and a Docker container. So I'll choose it as code. And then here you can choose your runtime. So I will choose Node.js. Now this is based on which particular language you want to choose. So these are the options you have. You have .NET, Python, Java. You can also do it in PowerShell as well, or you can have a custom handler. But for this example, let's try the Node.js one. And then you can choose the version. So currently the versions available are 12 and 14. So let me just choose 12. And then you can choose the region. Then next I click on hosting. So whenever you create a function app, there is always a storage account that is associated with it. You can either create a new storage account or associate with an already existing one. So for this example, let's create a new storage account. And then you choose an operating system. You have the option of either choosing Linux or Windows. So let's just choose Windows. And here is where you choose the type. So here are the three types that are available. So this was discussed in the previous chapter. So there is a consumption, there is a premium, and then there is the app service plan. So let's choose the cheapest one, that is the consumption plan. I'll click on this, click on monitoring. And here you can also choose application insights. So the default is yes. So application insights lets you monitor your application, and it detects anomalies or any diagnostic issues can be resolved by using application insights. So I'll click on next, and this is just a basic tag, and you can just click on review and create. So here it's validating all the options that you have chosen. Okay, everything seems to be okay. So I'll just click on create to create my function app. So this is how you can create your function app using your console. Okay, so our deployment is complete. So now let's go to that resource that we've just created. So let me just click on go to resource. And this is currently my function app. So you can see that it's in the subscription that I had mentioned. It's in Central US, and it's in the resource group that I had just created, and it's using Windows, and this is the URL to access that particular function app. So if you open this particular URL, you will get this particular window. So currently there are no functions that are running in my function app. So the next thing that I need to create is a function within my function app. So to do that, you can just click on this function and you can create a basic function. To do that, let's just click on create. And here you have the option of creating your function either in the portal or using VS Code or using any other editor. So what I'll do is in this particular chapter, I will develop in the portal, and in the subsequent chapters, I'll use VS Code to develop my function. So for this particular chapter, let's just choose develop in portal. And I want it to be an HTTP triggered function. So let's just click on this. So this is the trigger that I talked about. So this will be again an HTTP trigger. And then let me click on create. So my function within my function app is getting deployed. So our function has deployed. So let's go and check the code. So this is the code that will execute when I trigger my HTTP endpoint. And to get the HTTP endpoint, you can just click on get function URL and you can just copy this. And let's just paste this and run it. So you can see that this particular HTTP has executed successfully. And what this is basically doing is just executing this piece of code. So remember in the previous chapter, I had talked about the triggers, the input and the output. Now to see those, you can just click on the integration tab. So this will tell you the trigger, the input and the output. So currently the trigger is just the HTTP triggered, and there is no input currently defined. And this trigger is executing this particular function, and that is the function that resides within this particular piece of code. And apart from that, the output is an HTTP response. So in the subsequent chapters, we'll tweak the trigger, the input and the output to create more useful scenarios. And the monitor is just to monitor your code. So if you click on monitor, it will give you all the logs for all the triggers that have happened. So you can just open this piece of code to get information about the execution. And then there is the function key to secure your endpoint. So there is a function key that is associated with this particular function. So this is the value of that function key. Now, whenever you're running this particular endpoint, you have to attach your function key to your endpoint. So if I just remove this piece of code, this particular function will not work. So to make your function work, you have to append your particular endpoint with the function code. Now to remove that, you can go back to your console, you can click on integration and you can just open this trigger, and within this function authorization level, you can just keep it as anonymous. So if you do that, then anybody can access this particular endpoint. So let me just save this. And now if I run this particular function, it should work without the function code, and you can see that it has. So these are some of the attributes of our function. So in the subsequent chapters, we'll be exploring more of the functionalities. So I will see you there. Okay, so in this particular example, what we'll do is we will create a function using our VS Code, and then that particular function will deploy to our function app. So let's do that. So the first thing we need to do is we need to install Visual Studio Code. So the link to install Visual Studio Code I will give in the description below, so you can have a look at that particular link and download your Visual Studio Code. So after you've done that, the next thing you need to do is you need to go to extensions, and here you need to type functions, Azure Functions. So let's install this particular extension. So let me just click on this. And you can see that a new icon pops up. Let's just click on this particular icon. So the first thing you need to do is you need to create a function. So to do that, just let's click on create new project. So let me just click on this. I will create my project in the same folder. So what I need is an HTTP trigger. So I'll just click on this. Click on enter. And here I need to choose what kind of authorization I need. So in our previous chapter, we had seen the difference between anonymous and function. So let's choose anonymous. Admin is something that I'll explain to you in a different chapter. So for the time being, let's just choose anonymous. Let's click on this. And what it's doing is it's creating a project in our local environment. And it creates an index.js file. So let's deploy this particular function in a function app. So to do that, you can click on this deploy icon. You can click on this. So here you have the option of deploying this function either in an existing function app, or you can create a new function app in Azure itself. So let's do that. Let's create a new function app and let's deploy this function in that. So let's click on create a new function app. Let me just call this my new VLC. Enter. So here I'll choose 14. And I'll choose this in Central US. So let's just click this. So what's happening now is it's creating a function app, and within that function app, hopefully this particular function will deploy. So let's just wait for this particular function app to finish. Okay, so my function app has been created successfully, and it's called my new VLC function app. You can also see the other function apps which are not created by VS Code can also be seen here. So once this particular function app has been created, you can always verify going back to your console. So if I go back to my console and if you open your function app, you can see that your function app has been created. So let's just open this. If you open the function, you can see that everything is in a read-only mode, because if you want to make any changes, you have to do it via the VS Code itself. So let's just click on this particular function. So everything is as it was in the previous section. So if you go back to your integration tab, you can see that again there's no input, there's one HTTP trigger, and the output response is also HTTP. Okay, so the next thing that we'll do is we'll just make some changes to this index.js and deploy this function again. So let's see what happens when we do that. So I've added a few words here, and the next thing I'll do is I'll just deploy this function again. So what I'll do now is I'll just deploy it to the same function app as previously. So this is the function app that I had used. So let me just click on this. And it will give you that message saying that, are you sure you want to deploy? This will overwrite a previous deployment. So I'll just click on deploy. And it's deploying a newer version of this function in that function app. And once that is done, let's go back to our function app again. And if you check the code plus test, you'll see that those few words have been added here as well. So that's how you make changes and deploy your function again. So that's it for this particular chapter. Now this was a very brief and concise description on the most important aspects of function app. Now as we keep going down this course, we'll discuss on more important and intricate details. So I'll see you then. So let's start this section by talking about a very simple application that we'll create. So we'll use a function app called function VLC, and it has a storage account associated with it. So whenever a file is uploaded to the blob storage, it will trigger the Azure function, and all that this Azure function will create is a copy of the input file or the input object, and it will store it in another file. So here the trigger is a blob storage and the output is also a blob storage file, and there is no input as such. So again, the trigger is a blob, the output is a blob, and the input is not there. So let's create this particular function. So here I'm in my function app called function VLC. So let's create a function. So let me click on function. I'll click on create. So I will be developing this in the portal itself. So here what I need to choose is the blob storage. So I'll click on the blob storage trigger. Click on create. And that's about it. So once you open your function, you will see these 4 tabs. So what we need to do is we need to first go to the integration tab, and here we need to tweak this particular code a bit. Okay, so let's open this particular trigger. So here you see that the binding is again blob storage. The blob parameter name is my blob. So this is an important name for you to remember. And this path is also important. So what will happen is this particular function, Azure function, will be triggered only when a file is uploaded in a folder of this particular name, and within this folder you have to upload the file. So this is an important thing to remember. So in your blob storage you need to create a folder of this particular name. And then there is the storage account connection. This storage account connection is already created in the configuration. So this is something that I will show you later on. So there's nothing to change here. So the only thing you need to remember is that you need to create a folder of this particular name. And within this particular folder, you need to upload the... Okay, so let's close this. So now let's look at the output. So I click on add output. So here what I need to change is I need to make the binding as Azure Blob Storage as well. So the parameter name is output blob. So this is something I need to remember. I'll just copy this. And this path is very important. So whenever a copy is created, it will be created in this particular folder. So we need to make sure that this folder is created. And another important thing I'll do is I will just change the name of this particular output file that I'll generate. I'll just keep this as new. And this particular rand GUID I will change to name. So this name is basically the same that I had configured in the trigger as well. So this name, so let's say I create a name called test. So what will happen is whenever a new file is created, it will be created by the name new-test. So this name will be propagated from the trigger itself. So that's about it. I'll just click on OK. So I've done the trigger and the output. Now the only thing I need to do is I need to tweak the code a bit. Okay, so I'm in my code right now and I just need to add one line of code. So the line of code I need to add is basically the context.binding.myblob. So this represents the input. I just need to copy it to the output, and this represents the output. So this is the same parameter that you had added in the integration. So let me just save this and let me show you again the integration. So I go back to my integration. So again, if I click on the output, this is the blob parameter name called output blob. So all that I've done is I've basically copied the value of the input parameter name to the output parameter name. So that's the only thing I've done in my code. So let's execute this. Okay, so now let's test a piece of code. So I've created two containers based on the input and the output. So this is the path for the input and this is the path for the output. So let me just open the input container folder. So here I'll just upload a particular file. So let me just upload this particular XML file. I'll click on upload. And now if I go to my output file container, so if I just open this, you can see that it got copied here as well. And it got copied with the syntax of new hyphen and the name of the file. So this is how you can check whether your particular piece of code has worked. So I hope this was a simple lecture for you. Let's have a few more examples in the upcoming lectures. So I'll see you there. Okay, so now let's talk about a second example. Now this is a very common use case. So in which I have a user and I pass the ID as an HTTP endpoint and I get the information about that particular user. So here the input is the storage account table. Here the trigger is user/ID, and this ID I will pass in the input as well. And all I need to do in the code is whatever value I get from the input, I just need to pass it to the output. So it's a very common use case and it can be done by just one line of code using this particular Azure function. So let's see how this is done. Okay, the first thing you need to do is you need to go to the storage account and you need to create a table. So let's do that. So I'll click on create table and I'll create a table called person. I'll click OK. And then what I'll need to do is I'll go to the storage explorer and I'll insert some values into this table. So I'll click on table, click on person, and here I'll click on add. So here I need to mention the partition key. So let's just give this partition key a value of test, and the row key I'll just give this as 1. So this is the ID with which I'm going to query the user. And I'll add a few more properties. I'll just have a name. And I will just add one more field. And let me just insert these values. So that's it. So let's go back to our function app. So I go to my function app. And now let's create a function. So let's click on create. So this is going to be an HTTP triggered endpoint as well. So again, I'll be developing this in the portal itself. So I'll click on create HTTP trigger and I'll click on create. Okay, so now let's go to the integration. I'll click on integration. So here I need to add the input as well. So I'll click on add input. Okay, so these are the options that you get. You can use Cosmos database as well. But for this example, let's just use the Azure table storage. I'll click on this. I'll just call this as input table. So this is fine. So the table name that I've given is person. So I just need to call this as person. And then the partition key I've given is test. So I'll add that as well. And here I need to add the ID. So this is basically the ID of that particular user. So again, I'll just give this as ID. And this I need to mention in my input as well. So yeah, that's about it. Again, the table name is person. The partition key that I've given is test. And this is basically the ID with which I'm going to query this particular table. I'll click on OK. So now let's go to the HTTP trigger here. Here I need to use a route. So this is the route that I'm going to use, and this ID represents the user ID. And let's make this as anonymous as well. So this is just going to be a GET request. So just remove the post. Yeah, that looks fine. So I'll just click on save. I don't need to change anything in the response. So response is again an HTTP endpoint, and the response parameter is res. So that remains fine. So let's go back to our function. So here the only thing I need to change is this particular response port message should be removed, and it should just be the context dot bindings dot input table. So whatever value that I get from the input table, I just need to send it to the response. So that's the only change that you need to make. So let's just save this particular code. And now let's just run it. So I'll get the URL. I'll just copy this. So here I need to enter the value of 1. And that is because I've just inserted one particular row in that particular table, and that has a row key ID of 1. So let's run this particular function. And here you can see that you get the information about that one particular user. So this is a very good example of how you can use your input. So I'll see you in the next chapter. For my third example, I'll give you possibly the most basic or most common use case in application development. So this is just a post request, and this post request will insert data into a database, and it will also return a value saying that your user has been added to a database. So here there is one particular trigger, and then there are two outputs. The first output is to insert data into the database, and the second one is to just return a message saying that your particular user has been added to a database. Again, there is no input for this particular scenario, and the data will be sent as a post body request. So let's create this particular application. So for this particular example, we'll be using the person table that we had created in our previous example. So let's go back to a function app. So here we need to create a new function. So let's just click on create. Here again, the input would be an HTTP trigger. So I'll click on this, click on create. So here let's tweak the integration. So I'll go to the integration tab. And here what I need to do is I need to click on add output. So I already have one output as the HTTP response. Here what I need to do is I need to create another output. So this would be an Azure table storage. Now you can use a Cosmos database as well. So that's probably something that you can do as an assignment. So instead of using a table storage, you can use a Cosmos DP to do the same thing. So I'll click on Azure table storage. And here all that I need to do is I need to mention the table name. So the table name that I have created is person. I'll click on OK. Then let's go to our piece of code. But before that, let's see if there's anything that we need to do for the trigger. So I'll open the trigger. Yeah, so here what I'll do is I'll create a route, and this route will be just user. I will make this as anonymous. And here it's not a get request, but just a post request. So I'll just change this to post. And let me save this. Now let's go to our code. So I'll click on the HTTP trigger to here. So the code change that I need to make is I need to add this particular line of code. So what this does is it adds the following values to the output table, and the values are basically the name, the sex of the person. You need to also mention the partition key and the ID of that particular user. So these three values, that is the name, the sex and the ID, I will send through the body. So that's the only change I need to do. So it's basically this particular line of code will insert the data into the table, and this will just respond, send a message back to the particular user. So let me just change the response body and just say user has been added. So this is a very basic template. You can always add validations and other such fixes on top of this piece of code. So my only intention here is to just explain to you how the binding and how the input and the output and the trigger works. So all that we need to do is we need to just get the URL. So I'll copy this URL and I will call my postman to send a request. So before doing that, let's just see if there are any values in the table. So I'll go to the Storage Explorer, click on tables. So you can see that there's no data currently in the table. So let's just create a request. So here I've created a request and I've added a body to this particular request. And again, it's a post request. So let's just click on send. So it returns a 200. So let's go back to our database and let's just refresh this. And you can see that a data has been added. So this is how you can do inserting into a database. Now, of course, this can only be done in your storage account table or in your Cosmos DB. So just do that as an example. This particular task, you can, instead of using your storage account table, just use your Cosmos DB to do the same thing. So if you have any issues with that, please do not hesitate to get in touch with me. So I'll see you in the next chapter. So now let's talk about a very important file called as the host.json metadata file. This particular file contains all global configuration that is applicable to all the functions within a function app. So if you want to go to your host.json file in your function app, you can go to your console and underneath the functions, you can open the app files. And here you can add your host.json entries. So let's look at some of the most major entries that you would want to add in your host.json file. Now, of course, I'll not explain to you all the functionalities because that would take up a lot of time, but I would explain to you some of the more important functionalities that you can add. So for example, if you go look at the sample host.json file, some of the important entries that you can add here is basically the function timeout. So the default function timeout here is 5 minutes. You can change this in your host.json file as well. So let's do that. So I'll just copy this piece of line and I will just add another entry in this particular file. So let's say you want to change the function timeout. I can change it over here. So let's just make it 1 minute. So currently, if I save this particular file, then my function timeout for each function within my function app is currently set to 1 minute. So let me just save this. Another important thing that you would want to change in your function app is the retry mechanism. So whenever your function fails within a function app, it tries to rerun your function again, and it does it for a maximum of 5 times, and the delay interval is 5 seconds. Now if you want to change this particular functionality, you can do that as well. So let's copy this and let's change this as well. So let's just make it as 2 and let's just change this to 1 second. So now whenever my function fails, it will just retry it twice, and the delay that it will be set would be just 1 second between each retries. Now apart from that, there are some binding related changes that you can make as well. Now those binding related changes you need to make within this particular extension object. So now let's look at an example of this. So let's click on this HTTP that you can make over here. So let's just open this, and here it says that configuration can be found in this particular page. So let's open this particular page. So here is an example of host.json setting that you can make for your HTTP binding. So a few of the important ones are you can change the root prefix. So the default root prefix is API. You can change that. And another very important change that you can make is you can add custom headers to your response object. So if you want to add a custom response, you can add it over here. So let's make a few changes within our host.json for HTTP in our next chapter. So I'll see you there. Okay, so let us change the host.json file for a particular HTTP trigger. So I'll take one of the HTTP triggers that we had created. So I'll just click on the get function URL. I'll copy this and you can see that there is an API that is associated with the endpoint. So the first thing we'll do is we'll remove this particular endpoint, and we'll also add a custom header to the response. So to do that, let's go back to our host.json setting for the HTTP endpoint. So what I need to do is this particular route prefix is currently set to API. So I'll just change it and I'll make this as empty. And I'll also add a custom header. So this is the basic custom header that I'll add. Of course, you can add any custom header you like. So just for the sake of this example, let's add a very simple custom header. So let's just add this particular example custom header that is given. So I'll just copy this extension. I'll go back to my function app. I'll click on the app files here. And all I need to do is I just need to paste that particular. So I'll just paste it here. And that's about it. So here instead of API, I'll just remove this and I'll add this custom header as well. So the rest can be the default. So these are the default values for these particular keys. So let it remain as it is. So let's just save this particular host.json file. And again, let's go back to our function now. So let's run this second example that I had shown you. So I'll open this particular function. If I click on this get URL, so you can see that the API has disappeared. So I'll copy this again. And if I run this particular endpoint, you can see that the API doesn't exist. So I'll just, and let's look at the response and see if there's any particular response header. So I'll click on the network. Let's just run this again. And if you click on the header, if you look at the response header, so you can see that this particular custom header has been added. So this is how you can add custom headers and add other properties to your HTTP trigger. So I will see you in the next chapter. So in this particular chapter, we'll talk about the function app configuration. So there is a configuration tab that is present under setting. But before we do that, let's look at one of our previous examples. So let's look at the HTTP trigger that we had initially created. So if I go to the integration, and let's open the input. So this basically is input Azure table storage. So if I go down, you can see that there is a storage account connection that is created for me by default. So this particular storage connection is linked to the storage account that is associated with this function app. But let's suppose that you want to create a separate storage account and you want to link that particular storage account with this function app. So how do you do that? So to do that, let's create a storage account first. So I go to my storage account. So here I have created a new storage account. So what I will do is I will link this particular storage account to my function app, and this is the default storage account that is associated with that function app. So let's discard this and let's create a new storage account. So this is the storage account I have created, and within that I have created a table. And this is again the same person table that I had created in my previous chapter. So the only difference here is that I will be linking this particular storage account. And if I view this particular table, you can see that there is one entry. So this is just the test one and my particular name. So let's associate this particular storage account. So let's go back to our function app. And what I need to do is I need to click on configuration and I need to create a new configuration here. So once I'm in my configuration, let me create a new application setting. So I'll open this and I'll just call this as VLC storage account. And this particular value is the most important part. So I go back to my storage account and what I need to do is I need to get the access key. So I'll open this. And what I need is this particular connection string. So I'll just click on show keys. I'll copy this. And all I need to do is I just need to paste it over here. And I'll click on OK. And that's the only thing you need to do. So let's go back to our functions. Okay, let's save this. Continue. And let's open our HTTP trigger. So let's go to the integration tab. And I'll open this particular inputs here. And the only thing I need to do is I need to just give the storage account connection. So I'll just open this. And this is the default. So we'll not choose the default. We'll choose the new storage account that we've created. So I'll just click on this. And that's the only thing you need to do. I'll save this. Now let's run this particular piece of code. So I go back to my code plus test. So I'll click on get function URL, copy this, and I'll paste it. So here I need to give 1 because the user ID is 1. And you can see that this works. So currently my function app is also connected to this particular storage bucket apart from the default one that is already created. So that is how you can use your configuration file to create new connections for your storage account. So I'll see you in the next chapter. Okay, this is going to be a very basic chapter. In this particular chapter, I'll just create a new configuration and I will display it in my application. So let's create a new configuration first. So I'll click on new application setting. I will just name this as environment and I'll give it a value of prod. I'll click on OK. And now let's create a function. So I need to save this. So let me save this, continue. So let's go back to our function, click on OK. And I'll create a new function here. So it's going to be a very basic HTTP function. So I'll make this as an HTTP trigger, click on create. And let's go to our code. Here I just need to replace the body. So what I'll do is I'll just display the environmental variable in my output. So the output is again going to be an HTTP response. So let's just do that. So it's going to be process.env and the name of my variable is environment. So let me just save this. And let's click on get URL. So if I copy this, so you can see that the value of that particular environmental variable is displayed here. So this is a very basic example of how you can use your environmental variable in your code. So I hope this was useful. I'll see you in the next chapter. Hi, in this particular section, we'll talk about the time trigger. So a very common use case is that you have a cron job that you want to execute at a certain time or after a certain interval. Then to do that, a time trigger is a very good option. So what you can do is you can link your time trigger with a Azure function. And once the time trigger executes or is activated, then that would cause the Azure function to execute as well. And after your job is finished or after your cron job is done or any other job, then you can send out an email via SendGrid to a particular administrator or any other individual who would want to know the status of that particular cron job. So let's look at an example of this. Okay, so before we develop our particular function, the first thing we'll do is we'll integrate our SendGrid account with Azure. So it's a very simple process. So you can go to your SendGrid accounts. You can just type SendGrid on the search menu and you can just open the SendGrid account. The first thing you can do is you can create a SendGrid account. So what you need to do is you need to choose a particular plan. So if you just want to do it for a small use case, then you can just go to your change plan and you can just click on the free 100. So this will not cost you anything. So I've already created a SendGrid instance in my Azure. So I will just type SAS and this is my SendGrid account. So all that I've done is I've just created via the previous screen and this is what you get as the output. So if you just click on the SendGrid, what it does is that it creates an account in the SendGrid website. So you can just click on this particular SendGrid website and then you are logged into the SendGrid instance. So here the first thing you need to do is you need to set up the API. So you can go to your settings and you can click on API keys and you can create an API key. So I've already created one API key, and this particular API key I need to use in my Azure function. So after you created your API key, the next thing that you need to do is you need to create a sender authentication. So you can go to your settings, and underneath that there is something called a sender authentication. So you can click that and you can create a new sender. So I've already created a new sender, and this sender email ID is admin_test@verylazycoders.com. So one important thing to note is that this particular email ID should have a domain that is registered in your name. So if you do not have that, then you'll not be able to do this single sender verification. So create a domain and set up an email on that particular domain, and then you can create a new sender. So creating a new sender is very easy. So the only thing that would be a little tricky would be creating a from email ID. So this has to be from a verified authenticated domain. So make sure you create a domain and set up an email on that particular domain. So I already have that, so it was pretty easy for me to do this. So once you've created your single sender verification, so that's the only thing you need to do. So let me reiterate. First thing is you need to create an API key, and then you need to create a new sender. Okay, so once you've done these two steps, you can go back to your Azure function, and the first thing we'll do is we'll create a configuration for our API key. So I already have created a key called SendGrid, and this particular key has the value of the API key. And after you've done that, let's go back to our function. So what we'll do is we'll create a timer trigger. So I'll click on timer trigger. And here I need to select time trigger. So I'll click on this. I'll click on create. So meanwhile, let me check the code that I need to use. So for that, I'll check my Azure Functions SendGrid. So this is the link that you need to use to integrate your code. So this particular link I will give in the description below. So all that you need to do is you just go to your JavaScript and you can just copy this particular binding and this particular piece of code. So I'll just copy this piece of code, and here what I'll do is I'll also need to change the email, the to and the from. So the from should be basically the email ID that I have configured in my SendGrid. So that should be this, and the to can be any valid email ID. So let me just copy this as well as the binding. So the binding is a SendGrid binding, and these are the values that I need to copy. And again, the to and the from should basically be the from should be the SendGrid sender verification email, this particular, and the to can be any valid email ID. So let me just copy this and let's create this particular function. So here I've copied my piece of code. So again, here the to is a valid email ID and the from is the email ID that I had configured, and I'm just doing a context.log and I'm just typing job over here. So here is basically where you will be doing your job or any cron job or any other activity that you would want to do. And after that, I'm just sending an email ID, and this email ID will have the subject of, so let's change the subject. So I'll just keep this as task finished, and I'll just put this as success. And let's go to the integration. So here the integration, the input is a timer and the output is again a SendGrid. So you can just open this, and here the values are basically the same values that are mentioned here. So I've just copied this and I've just pasted it over here. So again, the important configuration here is the SendGrid key. So this is the key that I'm getting from my configuration. So I've just chosen this particular key, and everything is just basic to, from, and the subject and the message. So if this particular message was not there in the code, then it would take it from here. So this is basically not a necessary field to have. Okay, now let's have a look at the trigger. So I'll open my trigger, and it has a schedule that looks something like this. So what this particular schedule will do is it'll run this particular trigger every 5 minutes. So every 5 minutes this particular function will be triggered. Now it can be changed based on the settings over here. Now how these settings are changed, is another topic altogether. However, I'll send you a link on how this can be changed based on the values that you want, and that will be in the description below, so you can just have a look at that and see how it works. So this is the important parameter here, and this is what decides how this particular trigger will be executed, or on what interval or on what particular time schedule this particular trigger will be executed. So that's about it. Let's run this particular trigger. So we have to wait for 5 minutes for this trigger to run. If you do not want to wait, you can just go to your code and test. And you can click on test run. I'll click on run. Click on run. Okay, I have executed it twice, so let's go back to our email ID. So you can see that I received this particular message twice. So this is how you integrate your SendGrid, your timer, to create a very common use case that you would encounter where you want to trigger a cron job, and once the cron job is triggered, you want to send an email ID to an appropriate user. So I hope this was a useful lecture. I will see you in the next. Okay, let's start this section by talking about the most basic use case when it comes to using a queue. So I have an Azure Storage queue trigger, and this particular trigger will just call an Azure function. So let's see how we can implement this particular architecture. So I'm in my function app. So let's just go to our functions. So I'll create a new function. Let me create a queue triggered function. So let's go down, and what you need to choose is the Azure Queue Storage trigger. So I'll open this. So here you give a name for your function, and here you need to specify the name of that particular queue which would trigger this particular function, and then again our usual storage account connection. So once you have created this function, the next thing we need to do is we need to create a queue of this particular name. So let's just copy this and let's create our function. So let's go to our storage account. This is my storage account, and let's go to the queue. So here I'll just create a new queue. So let me open this. I will just paste that particular name and I'll click. And once this particular queue is created, let's open this. And here what I need to do is I need to add a message. So let's add a message. So all that I'll give in the text is just a value this. And here you can just give a random text. So I'll just say this is from my queue. And that's it. Let's just click on OK. So let's refresh this. Okay, so you can see that there is no result. That means our function has read this particular message in the queue. So let's go back to our function. So here I'll open my queue trigger too, and let's go to the monitor. You open the monitor, and here you can see the particular message from the queue. So this is how you can use your queues to invoke your functions within a function app. So I will see you in the next chapter. So now let's look at a very common use case for a queue. So here in this particular architecture, I have a queue trigger, and within the queue trigger, I will send a particular message, and this message will be the name of an object or a file that is contained within a particular input folder. And apart from the queue trigger, I also have an input storage account, and this particular storage account will point to the folder within which the particular file that is mentioned in the queue trigger is present. And based on the message of the particular queue trigger, it will pick up the appropriate file from that particular input folder. And once that particular file is picked up, the Azure can process it in any way it likes. So for example, if it wants to check for the name of the file or for the size of the file, or whether that particular file has something inappropriate, then that kind of task can be performed by the Azure function. And once it is done, I can put that particular processed file into another folder called the output folder, and that output folder will also be present within the storage account. So this is a very common use case, and you can also add a SendGrid to this particular application. So once the process has been completed, and once the file has been processed. You can also send a mail to a SendGrid user. So let's look at this architecture in real life. So I'm back in my function app. So first thing I'll do is I'll click on create, and I'll create a queue trigger again. So it's going to be the Azure queue storage trigger. I'll click on this and I'll click on create. So once you've created your function, you can go to your trigger and you can just check for all the parameters. Again, I'll be using the same queue that I had used in my previous chapter as well. So this remains the same, and this is just the parameter. So everything here is fine. So I'll just close this. And the first thing you need to do is you need to add an input blob. So I'll click on this. I already have added one. I'll just show you the parameters. So here again, the input is the Azure blob storage, and the name of my input parameter is my input blob. So this I will use in my code. And this particular path is very important. For this contains the name of the object or the file. So the object would be within the in container folder, and the name of this particular object is basically queue trigger. So this queue trigger points to the message within the queue storage. So whatever message that you send from the queue storage, that particular message will be populated here. So you have to make sure that the message contains a file name that should be present within this particular container, else it will fail. And then everything else is the same. So this is basically the same Azure Web Job Storage. So this contains the key for that particular storage account. So let me close this. And the output is the same as well. So the output, again, the name of the parameter is my output blob. And again, this is the path for my processed file. So I will create an output container, and whenever a file, an input file is processed, it will be sent to this particular output folder, and it will have this particular name. So this will be again the name of the file, followed by a suffix called copy. I will just change this and I'll just call this as processed. And this is again just the file name. So this is all fine. And this is our code. So let's just open this particular piece of code. So here is where your processing will happen. So this processing can be anything from checking the size of your file, your input file, and checking whether the name of your input file is correct or not. So it's based on your application on how you want to process that particular file. And once the processing is done, all that you need to do is you need to send this particular file to the output blob. So this will create a file within the output folder, and that file will have a suffix of processed. And that's the only thing you need to do. So let me just save this and let's run this particular application. So I go back to my storage account. I'll open this. So here I have two folders called input container and out container. So I will create a file within the in container. So this is the name of my file. So what I'll do is I'll just copy this. And then I'll go back to my queue. So let's open the queue. And within this particular queue, I'll just paste that particular file name. So I'll click on add message and I'll just just paste that particular text here. Click on OK. Just refresh this. And let's go back to our container here. And let's open the output container. So you can see that this output container has got a file called a.processed, a.ping/processed. So that means that that particular piece of code has run. So this is how you can use your queue along with your blob storage to create architecture like this. So I'll see you in the next chapter. In our previous section, we had used the storage account queue, and in this particular section, we'll learn about the service bus queue. Now, what are the differences between both of them, and which one should you choose? Now, that is based on the solution that you want to design. Now, for example, if your solution needs a first in, first out guaranteed service, then you would need to choose a service bus. And also, if your solution needs to support automatic duplicate detection, then also you would need to use your service bus. And if your application needs to handle messages greater than 64 KBs and with a limit that wouldn't exceed 256 KB, then service bus is the solution for you. And again, your service bus queue should not grow more than 80 GB if you're using a service bus. And another point to note is that your service bus supports AMQP standard-based messaging protocol. And last but not the least, if your particular solution needs to support at most one delivery guarantee, then you should use service bus, and this is not provided by the storage account queue. So there are other factors involved as well. So there is a link which contains all the documentation based on which you can choose whether you need to use your service bus or whether you need to use your storage account queue. So I'll see you in the next chapter. So the first thing that you need to do is you need to create a service bus directory. So I've already done that. So let's just open this. So once you're in your service bus directory, the first thing you need to do is you need to create a queue. So I'll go to the queue, and here I'll create a queue. So let me just create one. So I'll just call this as my queue. And I'll just leave everything as default. So let me just click on create. And once you've created the queue, the next thing we'll do is we will create a function that will be triggered by this particular queue. So to do that, let's go back to our Azure function. So I'm in my function app. So let me just open and let me just create a function. Again, I'll develop this in the portal itself. And this will be an Azure Service Bus queue trigger. So I'll just click on this. I'll click on create. So here, let me go to my integration tab. So I'll click on integration. I'll click on Azure Service Bus. And here I just need to change the name of my queue. So the name of my queue is my queue. And everything else remains the same. So I'll be using the service bus. So it's already created a service bus connection for me. So I don't need to do that. And let's just leave the parameter name as it is. So let's see what happens once that particular queue gets triggered. So I will just save this. And I'll go back to my queue. And here I have the option of triggering a message to this particular queue. So to do that, I'll just open this particular queue again. And here what I'll do is I'll go to the Service Bus Explorer. And here I will just send a text plain, and I will just write a message and send this particular message to the queue. And let's just send this. So once this particular queue has been sent, it will trigger that particular Azure function that I've just created. So I'm in my function again. So if I click on the monitors, you can see that this particular queue has been triggered and it has sent the appropriate message. So this is how you can use your service bus queue to trigger Azure functions. So I'll see you in the next chapter. So apart from queues, another very commonly used architecture is the topic and subscription. So how this particular architecture works is that you send a message to a topic, and any particular application or subscriber who is subscribed to that particular topic will receive that particular message. So here in this particular example, I've created an HTTP trigger that will send a message to a particular topic, and whichever application or whichever Azure function that is subscribed to that particular topic will receive that particular message from the topic. So let us create this particular architecture. So the first thing I'll do is I'll go to my service bus and I'll create a topic. So I'll click on topics, and here I'll create a new topic. So I'll just call this topic as my topic. So let's enter this particular topic. So the next thing I need to do is I need to create a subscription. So to do that, you can just go to the subscription. So this is basically within that particular topic. So within that topic, I'll click on subscription and I'll create a subscription. So let me just click that. And I'll just call this as my subscription. And I'll click on create. Okay, I'll just keep this as 1. I'll click on create. Okay, so this is done. So let's go back to our function app. And the first thing we'll do is we'll create the first part of our architecture, that is an HTTP trigger that will send a message to that particular topic. So let's click on create. So this will be an HTTP trigger. So I'll click on HTTP trigger. I will just call this as my topic HTTP trigger. And let's just make this anonymous, and let me click on create. Okay, so I'm in okay, so I'm in my particular function. So let me just click on integration. Click on HTTP request. I'll just call this as topic example, and this will be just a post request. So let me just remove the get, and let me save this. I'll go to the output, and here I need to add a separate output. So here I should click on Azure Service Bus, and then I need to choose topic, not queues. And here I need to give my topics a name. So my topic is basically the name of my topic. So I'll click on OK. So everything else is basically the same. So another thing I need to do is I need to copy this message parameter name. And within this particular message parameter name, I need to store the message. So I'll click on OK here. And then I go to my function. Here I'll just remove the unwanted code. So let me just remove this, and I'll do a context dot bindings, and I will say whatever I get from the request body, and the body would be just, for the HTTP, the body would be just a very simple message sent to the topic. So this looks fine. So let me click on save. So we'll create another function, and this particular function will read this particular message that we've sent. So I'll click on function. I'll click on create again. And if you go back and look at the architecture, this particular architecture would have an input of a topic and a subscription. So here I keep going down, and here I need to choose the Azure Service Bus topic trigger. I'll click on create. I'll go up to my integration. And here I need to choose the topic. So again, the topic would be the same. This would be my topic. And here I also need to choose the subscription, so that this particular Azure function is connected to a subscription. So the subscription that I had created in my previous slide was basically my subscription. So this is the name that I would want to give. And everything else remains the same. So whenever a message is sent to the HTTP, it will be sent to this particular topic. And because this particular function is registered to this particular subscription, this particular function should receive that particular message. So everything else should be the same. I'll click on save. So all that I need to do is I need to call the HTTP trigger to initiate that particular message into the topic. So let's do that. I'll go back to my function again. So let's go to our code plus test. And all that I need to do is I need to just click on test and run. So the message that I'll be sending would be this particular message. I'll click on run. I receive a message saying that the message has been sent to the topic. Now let's go back to my other function. And here if I go back to my function and if I look at the monitor, you can see that this particular message has been received by this particular function. So this is how you can use your service bus service to create topics and subscriptions. So I'll see you in the next chapter. Okay, so now let's talk about Cosmos DB. So Cosmos DB is another very popular serverless serving that Azure provides, and it is a fully managed NoSQL database. So let us talk about a few features of Cosmos DB. So here the most important feature is basically that it is a fully managed service, so you do not have to worry about the underlying architecture. And it has a lot of SDKs present that makes it possible for you to run it on different platforms and different languages. So to get more in-depth information on all the features, you can just go through the link that is provided in the description below. And that particular link is also mentioned in this particular slide. So just go through this particular link and see all the features that makes Cosmos DB very desirable. So I will see you in the next chapter. So now let's look at the Cosmos database resource model. So initially you create a database account, and within this database account you create a database, and this database will contain a set of containers, and each container will contain a set of items. So the items can be considered as rows in a particular table, and each item will have these following set of properties in them. So they include the RID, which basically uniquely identifies a particular item, and the other important one is the underscore TS, which is basically the timestamp of the last update of the item. So let us create our database resource model. So let's go back to our UI. The first thing we need to do is we need to create a database account. So I am in my Azure database console. I'll click on create and I'll create an account. So I'll click on create here. And here the important thing to note is you have the option of capacity mode. So you can either choose a provision throughput or you can choose serverless. So if you choose provision, then you can set a certain capacity for your database account. Whereas if you choose serverless, you don't need to do that. So based on your particular traffic, the throughput will increase or decrease accordingly. So once you've created your particular database account, you can go back to your console and you can see that I've already created a particular account. So the next thing you can do is you can open this particular account, and so the next thing you need to do is you need to create a database, and within that database you need to create a container. So you can go to your data explorer and you can click on new container. So the first thing you need to do is you need to create a database. So I will just call my database as persons database. And here you can either auto scale your database throughput or you can choose it as manual. So let's choose manual. And here you need to set a capacity for your particular database. So I will choose the minimum. So the minimum if you choose manual is 400. So let it remain as 400. And the monthly bill that you would get is around this much. So that is fine. So after you've done that, the next thing you need to do is you need to create a container. So the container, like I said, is akin to a table. So I will just call this as user. So the partition key is a very important field, and it's based on this particular key that you give here that your data will be partitioned. So I will just leave it as default. So I'll click on OK. So this is the person database that I had created, and it has a container called user. So let's add some items into this particular container. So to do that, you can just click on new item. I will just call this as my new item, and let me save this. So you can see that my new item has been added, and it has the ID field, and it also has the other fields that I had discussed in the previous chapter, that is the underscore RID and the underscore TS. So this is the timestamp and this is the unique identifier for this particular item. So that is it for this particular lecture. In the upcoming lecture, I'll discuss on how you can connect your Cosmos to your Azure function. So before we talk about the integration of Azure function with Cosmos, let me explain to you a concept of change feed. So change feed listens to any changes that happens within a container and sends a trigger to the Azure function. So these changes could include anything from an insertion of an item into a container or even updating an item within a container. So let us look at how you can integrate Azure with Cosmos. So I'm in my Cosmos database account. So let us try to integrate the collection that we've created, that is the user collection, with Azure function. So to do that, you can go to your settings and underneath you can find add Azure function. So let's open this. And here you need to choose the container. So the container again is just one because we just created one container within the person database. So let us choose this. And then you need to choose the function app within which you want your function to reside. So I currently have just one function app called function VLC. So I'll just choose this. And then I need to choose a name for my particular function. So I'll just call this as Cosmos trigger. And then I need to select my function language. So again, I have just a choice of either C# or JavaScript. So I'll choose JavaScript here and click on save. So when I save this, it will create a function in my function app called Cosmos Trigger, and all the settings will be automatically done for me, so I don't need to worry about anything. So let's just wait for this particular function to be up. So let's go back to our function app. So I will click on function app here. And let's click on functions. So you can see that my particular function has been created and it's called Cosmos Trigger. So let's open this and let's click on the integration. And you can see that everything is already pre-populated for you. So the database name is person, the collection name is user, and it also creates a connection string for you. So you don't need to do anything. And it also creates a new collection called leases. So this is needed for your change feed. And apart from that, there is nothing. So I'm back in my Cosmos DB UI. So if you go to the Data Explorer, you can see that a new container called leases has been created. So this is basically needed for the change feed. So what we'll do instead is we'll go to a user and we'll insert a new item here. And this insertion should cause the trigger to execute that particular new Azure function that we've created. So let me just add a new item here. Call this as ABC and let me just save this. And once I save this, it should trigger this particular Cosmos trigger. So let us just go to the monitor and check whether there's a new entry here. So this generally takes a few minutes to execute. So that's it for this lecture. I will see you in the next. So this is going to be a very important chapter. In this particular chapter, we'll create a backend. And once we've created this backend, we will find ways in which we can secure our backends. So the first important task is to create our backend. So for this, I'll be creating a new function app called VLC Cosmos. And within this, I'll be creating two APIs and they would be HTTP APIs. So again, the input binding would be the HTTP trigger, and I'll have another input binding, that is, it is connected to the Cosmos database, and the output would be the values that I get for that particular partition key and the ID. And the output would be sent again back to the response. And similarly, I'll be also creating a post request. So a post request would have the partition key, the ID, and any other information that you want to store within that particular document. And again, the output binding here would be the Cosmos database. And I will also send a response back to the user saying that the item has been added. So let us start by creating our functions. So before we create our backend APIs, let me show you how my data is structured. So I go back to my Cosmos database account. I'll click on Data Explorer. So I have a database called person, and within this person database, I have a collection or a container called user, and I'll be retrieving as well as inserting values into this particular container. So let's look at all the values that are currently available. So currently it has so many items in it. So let me just open one for you. So you can see that the ID here is the name, the partition key is the city, and the role is just a senior developer. So the first API we will create would be to get information for these particular items. So let's go back to our function app. So here in the function app, the first thing you need to do is you need to go to the configuration, and here you need to add a new configuration that will give you access to your Cosmos database. So what you need to do is you need to go to your Cosmos database again. You need to extract this particular key. So you can just click on this key, and here you can copy your primary connection string and you can paste it over here for this particular name. So that is precisely what I have done. So once you've done that, let's start by creating a first function. So I go to my functions and I'll create a HTTP trigger. I'll click on this and I'll click on create. So let's go to the integration first. So let's click on the HTTP request. So here let me give a route. So the route that I will give would be user, and I've also mentioned the partition key and the ID. So here I need to add the partition key, and here I need to add the ID. And for this corresponding partition key and the ID, I'll get the information. So here everything else is the same. So let me just make this as an anonymous so that anybody can access it. And this is again just a GET request. So let me remove the post and I'll click on save. okay, once you updated the trigger, let's go to the input. So I'll add an input, and this has to be a Cosmos DB. So I'll click on Azure Cosmos DB. Okay, here let the parameter name be input document. The database name here is user. Sorry, the database name here is person. And the collection name is basically user. And of course, it automatically populates the database connection string. So here what we need to do is here we need to mention the ID as well as the partition key that we receive from the trigger. So again, here the ID that I have mentioned is just the ID, and the partition key is the partition key ID. So this corresponds to the values that I had added in my HTTP trigger, and everything else is the same. So I can click on OK. I'll click on the HTTP response. Let the response remain as it is, so I don't need to change anything here. So the next thing I'll do is I'll just fetch this particular input document. I'll go to my HTTP trigger. And here I just need to change one single line of code. So the input binding that I get, I just need to send it back to the response. So that is precisely what I've done here. So here, whatever I get in the input, I just send it out to the response, which is the output. So that's about it. Let's run this particular URL now. So I'll click on get function URL. I'll copy this, paste it. So here I need to mention the partition ID and the ID. So the partition ID here is basically a city. So I have a city called Bangalore, and ID is basically the name. So I'll just give this name as Rohit1. And here you can see that I get the appropriate response. So that is it for this particular lecture. In the next lecture, we'll see how we can create the next API. So I'll see you there. Okay, so let us create a second API. So let me click on create. Again, this is going to be an HTTP triggered API. So I'll click on HTTP trigger and click on create. So here, let me go to my integration tab. I'll click on the trigger. So the route that I will give will just be the user, and all the other information I'll be storing in the body itself. So here, I'll just remove the get, and this should be a post request. And everything else is the same, and I'll make this as anonymous. I'll click on anonymous, and let me save this. And now let's go to the output. I'll click on add output here, and here I will choose Cosmos DB, and let the parameter name be output data DB. So I'll just copy this, and the database name again here should be person, and the collection name is user. And that's about it. So I'll just click on OK. So now let's write a piece of code. I'll click on HTTP trigger. So now let's write a piece of code. So let me just remove this default code. And what I'll do is I will just add my context dot bindings dot, and whatever I get in the request.body, I will just insert that into the output document. So that's the only line of code. And here I just add a line saying that it has been updated. Now here this particular piece of code lacks validation. That's something that you can add on your own. So that's the only thing that you need to do. Everything else is perfect. So let me just click on test and run. And here what I need to do is I'll just click on, so here I just need to add the value. So I'll just add the ID as another name, and let's keep adding values. So again, the foreign key is another city, and I can also add a role, and you can keep adding more and more information. So let me add also the phone number. So I'll just keep this as 1, 2, 3. So let's run this particular piece of code. I'll click on run. And it gives a response DB updated. So now let's go back to our Cosmos DB and see if it has been added. So I'm again in my database. I'll click on the data explorer. So let me open the user and I click on item, and you can see that this particular item has been. So this is how you create an API to insert values into your Cosmos DB. So I'll see you in the next chapter. So now let's talk about the first way in which you can secure your Azure functions. You can use something called as function access keys. Now there are two kinds. There is the function access key and then there is the host access key. So function access key is specific to a particular function, whereas using a host access key, you can actually have access to all the functions within that particular function app. There is also something called as a master key. So this master key is also able to have access to admin level APIs. Now master key is only specific to an admin and it should not be distributed or given to clients to run APIs. So now let's look at how these things work. So let us start by creating function specific keys. To do that, you can go to the functions. You can select any specific function. So let me just click on HTTP trigger one. And here underneath function keys, you can just select this. And you can see that there is a default function key. So let's create a new function key. So let me just click on new. I'll just call this as a new function key. And I will leave this empty. So if I leave this as empty, there will be an auto-generated key. So let me just click on OK. Then I need to go to my integration. So let me click on integration. I will click on the HTTP trigger. And here, instead of anonymous, I need to click on function and I click on save. And then let's go back to our code plus test. Here, just click on get function URL. So here you can choose the key that you want. So what I have created is the new function key. So I'll just click on this and I'll just copy this to my dashboard. And you can see that a new key got created here. So what I need to do here is just enter the partition ID and the ID. So the partition ID here is Bangalore. And the ID here is my name. And you can see that it works. So now let us focus on creating host keys. To do that, you can go to the app keys. And here I'll click on new host key. Again, I'll just call this as my new host key and I'll click on OK. So this particular host key is applicable to all the functions within this particular function app. So I'll go to my function again. I'll click on HTTP trigger one. I'll click on get function URL. And here what I'll specify is the new host key one. So this is the host key that I had created. I'll click on this, copy this, and let's try to run this particular function now. Again, similarly, I need to give the partition ID and the ID. And you can see that this works as well. So this is how you use your function key and your host key. So now let's look at the admin key and let's see how that works. Now to access your admin key, you can go back to your console, go to integration. And here what you need to do is you need to change this to the admin key and click on save. So now if I run this particular endpoint using the host key, let's see what happens. You can see that it has no access. Now to run this particular function, you need to use the admin key. So let's try to do that. So I go back to my code plus test. So here, if I click on get function URL, I need to choose the master key. So this is the admin key that I have. I'll click on copy. And now if I run the same function, it should work. So you can see that this works. So you must remember that when you configure your HTTP to admin key, then only the admin key can access that particular function within the function app. All the host keys and the function keys will cease to exist. So I hope this was a useful lecture. I will see you in the next. Okay, so now that you've secured your Azure functions, now the next thing that you would want to do is you just want to restrict access to those people who have access to your Active Directory and nobody else. So let's see how you can do this. Now to connect your function app to your Azure Active Directory, you can go to authentication. And here you can add provider. So you can just click on add provider. And here you can choose Microsoft Active Directory. Click on next. And here you have the option of either creating a new app registration or you can already use an existing one. So let's create a new app registration. And here you also need to specify as to what kind of tenant you want. Do you want to give access to just this particular tenant, or do you want to give access to multiple tenants? So let's just give access to this particular tenant that we currently are in. So I'll just name this as VLC backend IDP. I'll click on add. And now let's go back to our function. So if you click on your function now, I'll click on HTTP trigger 1. So I'll go to my code plus test, and here I'll click on get function URL. I'll copy this and let me paste this in another browser that is not connected to my Azure ADs. And now what I'll do is I'll just go to my incognito mode. I'll click on a new incognito window, and here I'll just give the partition ID and the ID. So let's run this particular function. So here it gives a response saying that you need to sign in. So you can sign into this particular account and access the particular API. So let's do that. So I'll be logging in using this particular user which belongs to this particular tenant. So let's click on next. And here I just need to give my password. I'll click on verify. And I will just accept this. And you can see that the particular API has been authenticated. So now let's revoke access for this particular user. To do that, let's go back to our console. The first thing you need to do is you need to go to your Active Directory. And under your Active Directory, you need to go to your enterprise applications. Here you need to open the application that you just created. That is your VLC backend IDP. I'll open this. And here in the properties, what you need to do is you need to have user assignment required. So currently it is no. So that means any user can access that particular API. So let's remove that. So let's make this as yes. I'll click on save. And I'll go to users. So what I'll do now is I will just remove access for this particular user. I'll click on remove. I'll click on yes. And now if I try to access that API, it should give me an error. So let's go back to our endpoint. So I've cleared my cache. So now let's run this particular endpoint again. So you can see that you get a page saying that you do not have permissions to view this directory or page. And that is how you can revoke access for this particular user. So I hope this was a useful lecture. I'll see you in the next. Okay, so now that you've used authentication using Active Directory, now let's see how you can use your Postman to validate your API requests. So most of the times you would not be using your browser, but most of the APIs would be called via your code. So you need to use an OAuth mechanism to validate your particular API. Now there are multiple libraries that can do that for you. And in this particular example, I'll be using Postman to do the same. So the first thing you need to do is you need to use Postman. Of course, there are many other softwares that would do the same as well, but I find Postman to be the most convenient. So the first thing you need to do is you need to get all the valid information. To do that, let's go back to our console. And the first thing you need to do is you need to again go back to your Active Directory. And now here you need to go to your app registrations. And you can click on all the registrations that you've created. So what we need is the registration that we've created. That is the VLC backend IDP. So I'll open this and I'll click on endpoints. And this will give me the OAuth endpoint and the authorization as well as the token endpoint. So I'll be just copying this and I'll be going to my Postman. I'll create a new HTTP request. And here under the authorization, I'll create a new OAuth 2 token. And here what I need to do is I just need to paste the relevant information. So I need to paste the OAuth URL. So this is what I need to paste here. And similarly the token endpoint as well. So I'll just copy this and I'll paste it here. And then I need to get the client ID and the client secret. So to get the client ID and the client secret, what you need to do is you go back to your browser and you can just copy this. So this is the client ID. So I'll just copy this and I'll paste it here. And now to create the client secret, you can go to your certificate and secrets. And you can create a new client secret and you can paste the value in Postman. So that's what I'll do. And the scope should be, And to get the scope, you can again go back to your endpoint. Click on API permissions. And you can just paste OpenID. So OpenID is basically what you need. You don't need the other scopes. So I'll just copy this and I'll paste it here. And the next thing you need to do is very important. So this particular callback URL, so I just need to copy this. And I go back to my console and I click on authentication. And here you need to add a new URI. So it's again, click on add a platform. So again, it's going to be a web. And I'll just paste this particular endpoint here and I click on configure. So once you've done that, you basically set. So now what you need to do is you just need to run this particular get new access token. So I'll just click on this button and you can see that you get a new token. So and here what you need to use is not the access token, but the ID token. So you can just go down. So you can just copy this ID token. I'll copy this. And I'll go to my headers and I just need to hard code this. So I'll just do an authorization. And I'll just paste the value. And that's it. That's about it. I just need to paste my endpoint. So I'll just click on send. And you can see that I get the 200 response with the appropriate value. So this is how you would use your API. So in your client application, whether it's a browser or a web application, you first need to install an OAuth to client and use all the valid information to create an OAuth token. And once you've got the token, you can just call your particular endpoint using that token. So I hope this was a useful lecture. I will see you soon.